Okay, one more person, get y'all in here. So let me just show you first where we're at. We're almost done. I posted, let me share the screen. Should have gotten an announcement just this morning. I posted the 14.4 on integration techniques, which is consumer and producer surplus. What you want to think of this is as an application of area between two curves. So I think it ended up being about a 40-minute video, and I do some examples. There's basically 5 homework problems to work through. And there's a 6th one that's a little bit more, you have to set up, it's a problem solving. So I'm gonna ask you to kind of go through that. And then we can maybe talk about that one on Friday. Friday, by Friday, I will have the last section ready on improper integrals. And since I do have the final exam sent to me already, I know that there's one problem from basically each of the sections. So some are worth 10 points. Some of the questions are worth 6. There's the 10 multiple choice. Each one's worth 6 points. The 4 essay answer ones, each are worth 10 points. So I'll give you more details as we go forward. My goal or my plan is next week to give you 3 quizzes, and they will be sort of open-ended. Each one will have, I'm going to shoot for 10 questions in each of the quizzes, and they will be multiple choice. Maybe I'll do 2 open-ended, 1 or 2 open-ended, just so you get that experience. And they will be really just based on getting you ready for the final exam. I will get them posted early enough, so my goal would be like for Monday, you would have already at least worked through as much of the test as you can, and then Monday during class time, we can work through those quiz questions together. The quiz will remain open, so you can still go. The goal is that you get 100% on those quizzes one way or another, but by doing that, you're getting experience with the types of questions that are going to be on the test as well. So we'll have at least 30 review questions that we'll do 10 each day, Monday, Wednesday, and Friday. If I'm able to, I'll get them all the quizzes posted early, but I'll post them as quiz 1, quiz 2, and quiz 3. And our goal will be that Monday we will address quiz 1, Wednesday quiz 2, and Thursday or Friday quiz 3. And I will use some of the problems off the review exam, and I may add some additionals, but I will again make sure that within those 30 questions, we definitely have very similar problems to the types that will be on the test. They won't be exactly the test questions, but they will be very close. And yeah, so what questions do you all have?
I have a quick little question.
Yes.
So not last time, when we did exam 2, I had a little bit of a freak out with the Zoom meeting, like it wouldn't let me in. Is it still going to be the same link as to the one you're using now?
I'm not sure. No, there's a new link. I do have a new link. I have either got it set up. Let me let's see. Let's go back here. I don't even remember what I do day to day anymore. Let's see.
We can relate.
Yeah, if I haven't set it up, I will get it. Let's see. We've got the recurring meetings. No, I don't have it set up yet. So I will set up a new link. The best way to get there is if you click on the Zoom meeting link within Canvas. What it'll be, it should be showing up, or not should, it will be showing up here as, what is it, Thursday, May 7th. So it'll be down here. These ones will start to disappear as we go through this stuff. And then, so you'll just have to click on here, and that should get you right into the meeting.
Sounds good.
Okay, that'll be the best way. I'll also, we'll maybe take a poll or something, but during finals week, we'll set up a review session, maybe a 2-hour review session. Although actually next week we will be going through it, but we'll set up another one for anyone who, a little bit more open-ended on which questions you want to take a look at.
Can we take a look at 14.2, number 3?
14.2. So this is an area between two curves. Which is actually a very good prelude into the 14 point, where it is 14.4. This is the right one? Let's see. Yeah. So what is going on? Number 3. Okay, so we want the area between these two curves. So what we're going to do is we're going to graph them both. One is y1. I'll call this first one y1. Call the second one y2. We're going to see which one's on top, which one's on the bottom, or if they change. And we're going to look over the interval from -2 to 2. So these are both x values. So from x going from -2 to +2, that's the y-axis will be here. Okay. So we'll do this.
For this?
Yeah. I wouldn't be able to do this without the calculator. In fact, you can see I've got it set up for today's, which we're really basically doing the same thing. I'm going to leave this y1 minus y2. In fact, for all of these area between curves, you could leave this set up. I'm going to do the other one too. So the other way, sometimes we take y1 minus y2. Sometimes we have to take y2 minus y1, depending upon which one's on top. So I'm just going to leave these set up. So this is going to be y2 minus y1 bars, y bars, function y1. So if you wanted to, you could leave these set up in your calculator, and then you could just turn them off when you don't need them, because you wouldn't use them at the same time. So I'm going to turn them off right now, but they'll be there when we need it. Okay, so we're going to do y1 first, is we'll just put in 2x 2x squared plus 7x minus 3. And then we're going to put, for y2, we're going to do minus x squared plus 4x plus 3.
I have a simple question real quick. So
Yes.
my calculator is all messed up. And the fact that like the graph shows like massive numbers instead of regular ones. How do I fix that? Like instead of it being the x values or the y values being like 1, 2, 3, 4, 5, it's like y is 1,300 and some random number. Is there any way to make it go back to regular?
What are you looking at, the table or the graph?
The graph. So if I'm on the graph and I'm like clicking up the arrows,
Okay.
it just goes at random numbers.
Yeah, what I would say is the easiest way is if you hit the zoom button. And you have a TI-83 or 84?
TI-84, yeah.
84, yeah. So just hit the zoom button. go to the the Z standard 6 is the one I use, because that'll turn it back to -10 to 10 and so forth. So you just go down and hit number 6, and then you'll see a window like this. And most of the stuff will be in the standard window, but others we might have to adjust the window.
Okay, there we go. Thank you.
Professor Crow, I'm drawing a blank real quick. How'd you get to y1 minus y2 again on the calculator?
Very good. So you just come down here. I'll just do it on a new one. You hit the vars button.
Oh, okay.
So this one, vars, and then you go to y vars, which vars stands for variable, but and then you go to function, and then you choose which ones you want to put in there.
Okay.
So notice we have them turned off, so they won't graph right yet. But once we figure out which one's on top and which one's on bottom, then we'll know whether to use y1 minus y2 or y2 minus y1. And I'm just going to leave them here because you'll use one or the other. And sometimes we might even end up using both. So we'll take a look at that. So we've got this graph, and we can see here's -2, right? In fact, I could, and then we're going to go to +2. So I'm going to so doing 6, let me, left someone out in the cold there in the waiting room. Sorry about that. Welcome. I'm going to shrink my window down just so we can see this a little clearer. You could work with this window, but since we're only going from -2 to +2, let's just have our window go from x -2 to x +2. Okay, so now we can see, okay, this one looks like there's an intersection here, but this is 1, 2. There's an intersection here, so we're going to switch. So notice the red curve, which is y2, is on top. The blue curve's on the bottom for this part, but then it switches. So we're actually going to need to use both of those functions. And I'm going to move my y up a little bit just so I can see the rest of this curve, the rest of the blue curve. So I come back to the window. Let's make our y max 20. I think that should be high enough. Yeah. Okay. So we're going to get the area between the curves is going to be this region here in the little sort of elongated football. And then it's also going to add the area in this sort of triangular shape here on the right. Okay. So we're going to get both of them. So this first part going in the, I just call it the football region, is actually, let's.
So the whole point of doing this is so we can figure out which one's on top, right? So like if we were to do this on paper, this would help us set up the integral, right?
Exactly.
Okay.
Yeah. So now I'm going to actually set up the integral that we're going to do. In the end, we actually don't need to, we've got everything entered into the computer now, or to the calculator, and I'll show you how you actually get the values. We don't need to, because they want us to check with technology anyway. We'll check our answer here, but so the first one, go back, make sure the red one is y2, the blue one is y1. Okay, so I want to take y2 minus y1, and that's going from x equals -2 until, I'm going to call that x equals 1, and then I'm going to verify that just to be sure. The way we verify that is we find the points of intersection. So I did second calc, number 5, intersect. And I'm on the first curve, so I hit enter, jumps to the second curve, I'll hit enter. And if I just hit a guess, it'll go to the closest intersection, which is going to be actually over there. And we see that is x equals 1, just like it appeared to be. I'm going to check the other one, second calc, number 5. This time I'm going to move my little marker closer to this other intersection. Enter, enter, enter. Oh, it still went back there. I bet you let's make this minus 2.5. It's probably just on the edge of the window. Now watch, I moved the graph out here so it actually has it. But you should do this just to check. Intersect.
So is there, so I'm not very savvy with calculators. I prefer to just do it on paper. So is
Okay.
there an easy way just to tell which one's on top and which one's on bottom, or is the calculator the easiest way to figure that out?
Well, the other way is you need a table of values, so you would be plugging in a bunch of X values. So I would think that would be
Yeah.
much more difficult without a calculator.
Okay.
Yeah,
Professor Lilcrow, I don't know if this is useful to those listening, but I'm following your calculator graph and I didn't change the numbers for the X minimum and X maximum, and I'm still getting the same intersections when you do the guess.
yes. Yeah,
So
you should.
I don't know if that helps people or not, but
Okay.
if you move it up and down and move it to the left like you did, you'll still get -2 and 9.
Okay.
9.
Very good. Very good. Yeah. So the sizing of the window, yeah, doesn't matter so much. It just it's sort of a preference of what you want to be able to see. And again, even though we may all have TI-84 calculators, there's actually two versions of the operating system, and some they work a little differently. So that's why you want to be comfortable with your particular calculator as you go through it. So yeah, some of them maybe you got that intersection without moving it, but basically if you can see it, you should be able to get it. Okay, good. So we know we're going from -2 to 1, so that's going to be one interval. And then we're going to go from 1 to 2. We see there's no intersection here, but we know our interval ends at 2 because that's what they're asking for. Okay, so then we're going to add the interval from 1 to 2, but we switch them. We put y1 is on top and then y2 is on the bottom. Okay, so we're going to calculate these two. And again, what you could do, you could replace it with these, and then there's a lot of algebra you're going to do with like terms and everything. But what I'll do is I'll show you is we're just going to integrate this y2 minus y1. So what I do is I come back to my y equals, and y4 is the one I'm going to turn on. I'm going to turn everything else off so it's not going to confuse me. And if you want to see doing it while it's on, I did one of them in the video where I left them on, and it's not so bad when you have a color system, but if it's black and white, you probably definitely want to turn them off. Okay, so this is going to graph y2 minus y1. So we go to the graph, and notice it's a different graph, but it's the combination of the two. And what we're going to do is we're going to get the area from -2, which since I moved my window, this is -2. Notice the endpoints have become the x-intercepts. That's because those places they intersect is if you subtract them, that's where it's equal to 0. Okay.
How do you make it so that they're invisible, like the ones that we don't need, the functions?
So when you're on here, if you go to whichever one you want to make, say like y1, you arrow over till you're hovering on the equal sign, and then you hit enter. This would now graph because it's a dark black. It's selected. If you hit enter, I just deselected it. So that's how it. There's still.
Okay, dark black is visible, and if it's not dark black, then it's not visible, correct?
Right.
Okay, perfect.
There you go. So yeah, these things could do a lot of different things, which, we could even do the different sizes. You can even come over here, change colors if you want. But a lot of that's beyond what, unless you're doing this on a daily basis, why would you do that? I don't know. So we've got the graph. We need to find the area under the curve now. So we go second calc number 7, and we're going from -2 to 1. So our lower limit is -2, enter. Our upper limit is going to be 1. And you'll see we've got the area between the curve is 13.5. So I write that down. That's my answer for this part. Now I just need to find this part. I'll get a number, I'll add them together, and that's our answer. Okay. So what I do for the next one, let me just show you, let me turn this one on, and this one on. So notice what we've done is it moves this area up into here. So when we get that area under there, we got it. But you kind of see how it gets to be so busy. But this intersection became the x-intercept. This intercept became that x-intercept, and this area under the curve is the same amount of area in between the curves.
What did you press to get that 13.5 again?
So then with just that one graph there, you go second calc, number 7. That's the integral. That's taking, when we did definite integrals, this is the way we can use the technology to get that. So I do number 7. And again, all it is going to get the area under the curve. And that's, if I had 3 graphs there, then I have to make sure I'm on the right graph. That's another reason why it's good to just have one graph at a time when we do this. The lower limit is our -2. So this is just from the integral. And then the upper limit is 1. I enter that, enter, and it visually gives me what I'm getting, and it gives me the answer down here. And it shows me I'm going from -2 to 1. So it shows me the 13.5.
Now, could you technically just use this for any integral?
Any definite integral, yes, any one we have the limits on.
Okay.
Now, the tricky part is with WebAssign, sometimes they want an exact answer, and that might involve a natural log or a e to the x or something. So there was a few that we've worked through that I said you really can't quite use this. But on most of them, on all the ones that are polynomials, or if it says approximate, then we can use this for any definite integral where we have limits of integration.
Just based on my calculator numbers, they're different from your values. I have 13.4958, and then it just keeps going on. Is that just something you'd want us to round to since yours is 13.5?
Yeah.
Okay.
So, and that's what I mean is there's different actual software in each, even though we may have both at the 84, there's different versions of the software, and sometimes it's doing all of this computer-wise, so some of them have more rounding than others. So yeah, you might see 13.4998 or something. We'll just round that to 13.5. Okay. Now sometimes if it wants an exact answer, if I would have got 13.3333, what I would know is I would change that to 1/3 because it's not going to accept a rounded decimal. And I've got ones that I've worked that way as well in the lectures. Okay, so then the last step is to do this part, y1 minus y2. So we come back here. I'm going to turn off the y2 minus y1, and I'm going to turn on the y1 minus y2. Okay, so you really need a combination of the paper because we're following along here with what we're doing on the calculator. So we're going to go y1 minus y2, but this one we're only going to do from 1 to 2. Okay, so we're going to do that graph now. And what we've got is we're going to go from here, we're going to get the area under the curve of this part. And again, there's no intersection here, but it'll stop at 2 because the problem said to stop at 2. So we do the same thing, second calc, number 7. The lower limit is this one here is 1. Enter. The upper limit is 2. Enter, and it shows us we're getting the area under the curve, and that is 5.5.
So for some of these that don't switch like this particular one did, you only have to do the first part, correct?
You got it, exactly. And that's why we really need to have some sort of graphing thing, because it would be just too difficult to get you. Otherwise, you'll have to put in so many values to see what's happening and to see whether they cross or not. Yeah, it's just, and that's what I had to do, and I make you feel, I had to walk to school in snow 5 feet deep and no, we didn't do that, but we did these without graphing calculators because back in the 80s, they just didn't have them. When I was doing my undergraduate work, and this, yeah, I struggled with these ones really hard because you'd have to know how to graph these. So what we do is we just add these. 5.5 is, that's a 0, carry the 1, that's 18 plus 1 is 19. And I think, let's go, I think I still have it here. That was number 3, right? Yeah, let's just check it. And again, since it is 19, it's 19.0, we're good. Some of these, let's just submit it. And yeah, it's correct. This one will be okay, that's okay. With these ones, I've worked some of these before. But they want us to round the answer to 3 decimal places, so we can just use the calculator on this one. Now this is one I've worked out, and the y-axis, it doesn't say round the answer, so it's actually going to want it's going to want an exact answer, and your answer is going to involve probably logarithms and e to some power. So take a look at this. We've worked this one before, and I did work this one with maybe slightly different numbers. They might be the same numbers, but in the lecture, I worked one example with this particular one, because since they're not asking us to round it, it's a little bit, we have to do a little bit more by hand. We can use the technology to check it, but it doesn't accept it as an answer.
I think that's one of those ones where it switches like the other one that we just did.
Yeah, and it may switch too. Let's see, e to the x.
Can we work through that one, because the y-axis part's kind of throwing me off? Just
well, the y-axis part, all that means is that x equals 0 is one boundary. Okay, so even though we can't just use the technology to get the answer, we'll go ahead and I'll clear these ones out. We'll graph it so we can see what it looks like. E to the x, so we go second e to the x. And the second one is just y equals 2. That's going to be a horizontal line. I think our windows will be okay. Oh, I want to turn this one off.
Would you press for E?
For E is the natural log button
Oh,
shifted. So it's above the natural log key, yeah. So let's go to the graph. Actually, let's come down a little bit just so it shows, because it's this little area in here. So I'm going to use my Y max as, since we're only going up to 2, actually I'll go to 3. And Y minimum, let's just make that -1. And all I'm going to do is bring the graph down so I can see more clearly. So what it's saying is the y-axis is one boundary. So we want just this little chunk here until, and see, they don't give us this boundary over here. We have to get that. That's the intersecting point. And it bears enough. You really need to use the algebra here, because watch, I'll go second calc, number 5, intersect. Enter, enter, enter. It gives me a number of 0.693142, but that's not going to work because I tried it. And it gives a correct numerical answer, but WebAssign doesn't accept it. What we need to do is the place where it intersects is where e to the x equals 2. Where these two graphs are equal, that's where we get that intersection. So for this particular problem, what you're going to do is e to the x equals 2. Take the natural log of both sides. The x comes down, so what we get is x equals natural log of 2. What you can see is that 2 is above and e to the x is below. Let me see if I can. So just for the setup on this, you're going to get the integral from the y-axis, which is x equals 0, until natural log of 2. Y equals 2 is on top, so that'll be 2. E to the x is on the bottom. and this one doesn't switch. So this is what you're working with. And I guess.
So how would you type the integral into WebAssign? Is it there?
Okay, so now we need to actually integrate this by hand because, yeah, how are we going to put this in there? So 2 integrates as 2x, right? This is like x to the 0, add 1, 2 becomes 2x. E to the x is just e to the x when I integrate it. So I still have minus e to the x. So that's how it integrates. So fortunately, they didn't get things too complicated. The limits of integration are from 0 to natural log of 2. So we plug in natural log of 2 for both of these x's. So
Is that an integral?
Which one?
The one
This-
you just put down, the natural log of 2 and 0?
This one here is no. This is I've actually already integrated it, and so this is how they do it. They put a straight line, and they just show that these are the limits that we're going to evaluate it at. So they plug in natural log of 2 at the front, and then we're going to subtract all of this with 0 plugged into it. Does that make sense?
Yeah.
Okay, so this one, so we have integrated it, and then we plug in our limits. So 2 natural log of 2 minus e natural log of 2. And then we subtract off what happens when we plug in 0. So that's 2 times 0 minus e to the 0. And then, so 2 natural log of 2, that's just a number, but we'll just leave it like that. E to the natural log of 2, e and natural log are inverses, so this just becomes 2, right? So this becomes minus 2. 2 times 0 is 0. E to the 0 is 1, so it becomes minus 1. There's a minus 1, so it becomes plus 1, okay?
This problem is wonderful.
Yes, it is. It is. It reminds you. So, and it's really the hard part of it all is the algebra. Yeah, we had to solve it. So our final answer, you get -2 plus 1. So what you need to put in is 2 natural log of 2 minus 1. That's what WebAssign will accept. The good news is if this is a multiple choice test, you could actually do it with the calculator. And then when you plug this in, turn it into a decimal. But for WebAssign's purposes, let's see, let me pull it up and I'll show you. What did we have? We had 2 natural log minus 1.
Now for these black and white calculators, it's very difficult to tell which one is top and bottom because the lines are just so trash.
Yes, I agree with you.
So it might be easier for people to have the black and white calculators to just download the one that you have.
Right.
Do it that way because that one's also free and you can see a lot more.
Yeah. And Desmos works. Of course, the problem is during the test, you have to be able to use your calculator, not the computer. I would like to see that change. Let me test this while we're at it. But that's what we're operating under. And actually, I'd like to see Desmos be able to be used because it is free and it's got the color and it does have a lockdown browser on it where we could actually, proctor and test it. But we'll have to get that through administration and it's not going to happen this semester. So, yeah, so that ended up being, and again, the reason I know this is I did it the other way, just using the technology, plugging it in and getting it. But it wouldn't accept it. I knew it was the right answer, but this is what it wants. These ones down here, I think we're okay. Because, yeah, so whenever you have polynomials, you're always okay. It's whenever you have e to the x or natural log. But yeah, get some practice and whatever tools you're going to be using for the test, use that. I use Desmos too because it's easy to scroll around and it kind of helps, it speeds up the learning. So it's not just because you can't use Desmos doesn't mean I would say don't use it at all. It gives you some experience with graphing and sort of seeing window size and what you need to do to adjust it. But yes, also definitely take the time to practice with the calculator you're using. And with that, I just had a thought. The other thing, if you're having a hard time like with the lines, the other thing you can do is you can go to the table, second table. So notice we've got Y1 and Y2. Oops, let me go to my table set. Let's start at, well, let's make it auto. It gives you a little bit. I can see that Y1 is below Y2 because it's smaller. And then I can see after, after 1, it crosses over. So you can also look at the table of values. Again, sometimes you have to play with that a little bit, making it not just change by 1, but maybe change by 0.5 or 0.25. You'll get to see more values that way. Notice as I go up, these I can see as always. So there's a few tricks that you can learn to help with the systems, but all right, what else? What else have we got?
Can we do 14.1 number 2 and 4?
1, this was 2, so let me get rid of that. 14.1, here we go. Which one first?
2 and number 4.
2 and 4. Those are going to be very similar. The difference will be, in fact, actually so similar. The difference is one has a negative, one doesn't. But let's see, what were we doing? Integration by parts. Okay, I had to think what we were doing. And usually the questions I think on the test, I'll make sure they tell you if you're going to need to use integration by parts, it will tell you use integration by parts. So let's, so again, this one is mostly going to be by hand. Let's just get a blank document.
Which problem was this on? Which 13 or 14 point what?
This is 14.1, and I'll copy it over. We'll do question number 2, and then we'll maybe look at the setup for question 4, but it should be very similar. So let me take a snipe of this. And again, notice we are back. There are no limits of integration. So this one, we're going to get a +C on it. We really can't use the calculator so much to help us with this one. Okay, so integration by parts. Let's do a little bit of integration by parts. Says that when we're integrating something that is, is u dv, we break it into parts and then it becomes v times u minus the integral of v du. Okay, so that's kind of what you're going to need to remember because they don't give you the formula. And then, come on. What we do is we get this little box thing. And I've got these, I uploaded ones where I worked through them and there's a couple extras at the bottom so that you can get to where you use it. So this is where u goes. Du goes down here. So this is the derivative. So we're going to take its derivative and put it down here. This is where v goes, and v will also go down here. So we just kind of do a copy. But notice we're separating this into a u part and to a dv part. When we have e to the x, that's the part we want to leave as our dv. So this will be e to the x dx. And this u part is the part in front, 2 minus x. And the reason we do this is when we take the derivative of 2 minus x, the variable disappears. So integration by parts, we're taking the derivative of one part and we're integrating the other part. Okay. So 2 minus x, when we take its derivative of a negative x is just negative 1 dx, or just negative dx if you want. So that's what makes it. Derivative of 2 is 0. Derivative of negative x is negative 1. To get v, we have to actually integrate this, and e to the x integrates as e to the x. That's what makes these ones hard, is they're so simple, it looks like magic. It looks like nothing happened, but we actually integrated the integral e to the x dx, and when it integrates, it's still e to the x. So it's a well-adjusted person. It knows who it is in all circumstances. E to the x is always e to the x. You take the derivative of e to the x, it's still e to the x. So it's just a really cool feature. And then remember this, now our pieces are all together. We take u times v, so 2 minus x times e to the x. So we just multiply the top two boxes. Then we subtract off these bottom boxes, which are now going to become v du. So it becomes the integral. I'm going to take this negative 1 sort of out front. So notice it's set up to have minus. This negative 1 comes out. It's going to make it a plus e to the x dx. Okay, so I took care of this negative 1. Let me just... that's how this became a plus. And we're not quite done yet. We've integrated part of it. Now we integrate this part again. So it becomes 2 minus x e to the x. And when we integrate e to the x, it's plus e to the x, and then plus a constant. And this is the answer we enter in to the WebAssign. We have integrated it by parts. And you'll see for number 4, the only thing that changes is what goes in here as u, because what was number 4? Number 4 was the integral, I think, was it x plus 1? Yeah,
And
x plus
just
1.
a note, guys, remember to put capital C when you put in the constant, or else it won't take it. Especially in the
Really?
test, yeah.
I did not know that. Thank you. Very good information here. So capital C's, not little c's. Good. Yeah, it was just x plus 1 e to the x dx. So it works exactly the same way. The only thing that changes is the u box. Instead of being 2 minus x, it's going to become x plus 1. Right, this part goes here, so we integrate, we get, oops, not 6, e to the x, just like we did there. And when we take the derivative here, we get, instead of negative 1, we get positive 1, because there's a positive here. So we just get dx, 1 dx. So it's all going to come out, except basically, you can see it's going to be x plus 1 e to the x minus e to the x plus capital C, okay? Because since this doesn't have the negative, it stays negative, right?
Is that an extra C?
Yeah, I just put that in and it did count as correct.
Okay. And what was the other question?
Is that a 6 or a C?
I should erase it. It was supposed to be an E from the start, and my brain just made me draw a 6. And so I scribbled it out, and now you can't tell what it is, right?
No worries.
So yeah, oh gosh.
Yeah, it seems like we all have the same problem because there's no red numbers in it. It's incorrect for me.
Okay.
That exact.
It counted as incorrect.
Yeah, incorrect.
Let's
I
see,
typed in
maybe,
the exact same thing you have right there. So
let's see, what did I do wrong? Let me take a look at it.
there are bounds. Maybe that has something to do with it. It's 0
Thank
to 1
you.
instead of.
Okay, yeah, I think I did this the first time too, as I said, oh, that's it, and then someone else said, okay, thank you. Come back here. It has boundaries, so I didn't read that close enough. And so instead of plus C, what we do, the integral part was correct. But we've got to take it from 0 to 1. So now in the front part, we plug in 1, and then we plug in 0 and we subtract it. So 1 goes in for x, so this becomes 1 plus 1, e to the 1, minus e to the 1. Second part, we put in 0 for x, so we get 0 plus 1, e to the 0, minus e to the 0. 1 plus 1 is 2, e, and since it's to the 1, we don't need to write that, minus e. This part, 0 plus 1 is 1, e to the 1 is 1, so this is 1, and this is 1. 1 minus 1 is 0. Did I get that right? Yeah, 1 minus 1 is 0, so you minus 0. So it's just going to be 2e minus e. How does that, let's see if that works. That works, okay, yeah, thank you. I did it twice in a row. I get on a roll and I'm a little lazy at times, you know, but my biggest problem is I don't read all the instructions and I don't look, you know, I say, oh, that looks just like this one, and I miss the details, and that's what you got to do with math. You got to look for the little things that are different. Thanks, Kyler. That's a good question.
Professor Little Crow,
Thank you.
I just have a quick question. I noticed on the Canvas on chapter 14, the Zoom lectures haven't been uploaded. I was just wondering if you weren't doing that anymore or if you were going to do that later.
The reason they weren't was I forgot to record them. So the ones that don't have them, and I don't think we did a few problems on some of those, but I'll check back to make sure. Let me, let's see. Let me make sure there was a day. There might have been a day where I forgot to upload it, but I think there was a couple days where I forgot to record. And of course I can't go back and get those. So let's see. Section 14.1.
Although the live lecture may have not been recorded, you have all the homework sections, right?
Yeah, I do have lectures for them, but the live sections, you're right. I will, thank you for bringing that up. I gotta believe I recorded something in these last few days that I just didn't get uploaded. So I will go back and I'll figure it out. So like this one, where should I put it? The thing is it's, what I'm doing is since today is Wednesday 4/22, I will put it here, although it doesn't really refer to section 14.4, right? Because we've been doing other sections, but that's the same thing with all these other days. I will figure out what day we did it on, and I will post those there for the ones that we have recorded. And I'll do that this afternoon, and basically anything that doesn't show up by this afternoon was one that we just didn't record. And I think it was, we were working on those days, we ended up working some things we had actually already worked anyway. So I think once we get it there, but yeah, thank you for bringing that up. I'm pretty sure we had one on Wednesday and maybe even Friday of last week. I'm pretty sure we recorded those. So I'll get those in there. And definitely I'll get today's in there. Okay, what time is it? Oh, we do pretty good at using the full class, and I want to appreciate you guys coming in. I know it's not everyone. There's about a 25% of you guys have been active in class coming through. The others, I know there's difficulties, and hopefully next week they'll become real active. But I think you're going to find that by being consistently active, it's going to make it a lot easier than trying to learn all this stuff in only a week. Because really, we're kind of accelerating. This is 4 weeks worth of material that we've gone through, at least 4 weeks. So after Fridays, the new stuff will be done, and we'll just kind of go back and review and get on things. And we've got 2 weeks, almost 2 weeks to do that. Okay. So we all good for today?
I think that should be it. Thank you.
Awesome. Thank you so much.
Thank you.
Take care, be safe, and we'll be back. See you on Friday.
Have a nice day.
All right, you too.
Have a nice day.
You too. Take care.